In this lesson, we'll talk about the Python functions map, filter, and reduce. Map, filter, and reduce are three important functions in Python. They bring in new functionalities to Python, in particular functionalities due to functional programming. I remind you that functional programming consists of treating functions as first-class objects, objects that you can manipulate, modify, and even pass on to other functions. Indeed, map, filter, and reduce will all take as argument at least one function. Let's see that in action. The first example I want to consider is map. Map takes as argument a function and a list and returns the result of applying that function to every element of the list. So for instance, if I construct the variable numbers to consist of all the integers between 0 and 9 and the variable cubing to consist of a function that takes one input and returns its cube, I could map the function cubing to every entry in numbers. And indeed, this is the code I've written here. So let's see that in action. Cubes is now all the cube powers of integers between 0 and 9. In this particular case, I've decided to apply map to a list. I could also have decided to apply map to an iterator, and exactly the same thing would have happened. This is also true for filter and reduce. Let's now consider filter. So filter is very similar. It takes as argument a function and a list. The difference is that the function is here assumed or understood to return a boolean, true or false. And the result, the output, is that filter will select all the elements in the list, all the x's in the list, such that function of x is true. So, for an example, let's consider the function isOdd. IsOdd takes as argument z and returns z mod 2. Now z mod 2 is going to be 0 or 1 if z is an integer, but that's interpreted by Python as true or false, so everything is fine. It will return 1 if z is odd, so this is indeed a selector function. Now I can use this selector function to select all the cubes that are odd. Let's see the results. Odd cubes returns all the cubes that are odd. Perfect. The next example I want to look at is reduce. Reduce applies slightly differently because it's recursive. So as an argument, it will take a function and a list, just like map and filter, except that it splits this list into a first entry and a sublist, which is really this remainder list. What's the output now? Well, the output will be the result of applying the function to that first entry and the reduction of the sublist by that function. So you see that reduce has to call reduce again. Now that might be a bit complicated, but if we consider an example, it will be much simpler. So the function here we'll consider is lambda xy returns x plus y. So this is just binary addition with two entries. And we can reduce the out cubes with this binary addition. What do we get? Well, we get the sum of all the out cubes. So if you check, 1225 is indeed the sum here. The interesting bit here is that this 1225 was obtained by taking 1 plus the result of reducing that particular subsequence, not including 1, by binary addition. Now how is that result obtained? Well, that result was obtained by taking 27 and adding to that the result of reducing all this with binary addition, and so on, up until all the computer has to compute is the sum of those two. You might have heard of map and reduce in the context of Google and large-scale programming. Indeed, the idea there is the same. We're distributing tasks over several different little parts of the data. This allows for much more efficient computing because it can be distributed more easily. So map and reduce, you can simulate this map reduce idea using the Python functions map and reduce. In general, map, reduce, and filter help avoid some loop constructions that are sometimes inefficient in Python, and they also help produce much better code, much cleaner code.